I'll get my comb out. Hold on.
Just as I hit record too, Jason. Perfect. Made it super awkward. Okay. So hello everyone. This is a contributor meeting. It is being recorded for history forever because bits never get deleted. My camera's off, so I'm so sorry. Today's discussion where the discussion topic was around CEP-7, maybe helping clear up some of the confusion, misconceptions about CEP-7, specifically storage attached indexing, and what that means, and just having a general discussion about implementation and how this is going to hit the project. So I think it's probably a good idea to just kind of level set and hit this from the top. Like the question, I'll tee up the question: is this SAI? Is this meant to replace other indexing schemes, or just be be yet another indexing scheme in the Cassandra ecosystem? I don't know who wants to take that. Seems like Caleb, you've been working on this for Caleb and Jason have been working on this for 300 years.
But, yeah, that's about right.
Yeah.
Yeah, so I think this probably at some point should be a little clearer in the CP, but the ultimate goal of the project is consolidation, and it is to take the existing sort of legacy secondary indexes that have been the table-based stuff that's been in the project for a long time, to take SASE and sort of subsume both of them, subsume the functionality of both of them, initially get to feature parity with them, then deprecate, and then ultimately replace them, and then in the future go beyond them and go beyond the capabilities that they have now. And I think the focus is initially the focus is, I think, on getting to that feature parity, but also being at a sort of a place of operational sort of maturity that neither of them ever really achieved. So does that make sense?
Yeah, I did somebody asked me, and I don't know if I have a good answer. I did get a question about SASE. Is SASE going to be deprecated and removed?
Yeah, so most people, I think here already know that SASE is sort of officially marked as an experimental feature in 4.0. I think you actually do at this point have to enable a flag in the Cassandra YAML or somewhere to create a SASE index in the first place. So I think we're already coming, at least there, the ergonomics of that should be in our favor.
Yeah, some of the immediate downsides and pitfalls of SASE were just the enormous amount of index space that it took on disk, and it just blew up your disk if you enabled it, and you didn't get a lot of bang for the buck. Is that part of the reason that this needs to be gone, or what are some of the downsides on SASE right now that this is replacing?
Yeah, I can keep going here, although at some point, I think I'll let other people jump in. But yeah, I think at the end of the day, the big leap that we make from legacy secondary indexes and SASE to SAI is it's in the local storage formats, and it's in the structure of things at the local level. So not only are the disk formats individually much more compact for SAI, there are also pieces of information that we keep in a centralized location, sort of per SS table. Because again, SASE and SAI index SS tables, not entire tables. And so there are bits of information that SASE, for instance, stores per SS table, per column, per table. And sort of structurally, SAI has moved a lot of that information to the SS table itself. So where you really start to see the benefit of SAI is, something that nobody ever does, right? Just indexes a crap ton of columns on a particular table. If you do that with legacy secondary indexes or SASE, you're basically, shooting yourself in the head. So
yeah, there's a chart in the CEP that shows the disk usage. So I think that's pretty.
It's pretty dramatic. I think the that's the, it's like, wow, that's a really big difference. I mean, and it sounds to me like, well, this is as I see it, and this is what's really important for the project too, is potentially by using SAI, you would need less tables, less data duplication just based on the syntax that you can use. And potentially you will need to store less data in your cluster for the same type of data queries. I just made a logical leap there.
Yeah, I think so. I mean, it may be able to give people a little bit more data modeling flexibility. Yeah, it'll give people a little bit more margin for error in terms of not modeling things perfectly off the bat.
I've wanted to, I mean, for user land, people to actually using it, storage attached indexes means nothing. That's definitely more internal land. But I've been wanting to call it something like column indexing. Is that an accurate term?
I mean, it's accurate in the sense that you know, you are from a schema management perspective and from a DDL perspective, you're attaching indexes to columns. I mean, they're parts of the index that would be shared between index columns. But yeah, I mean, by and large, that's what it is. I mean, basically aside from some of the proprietary stuff that, you know, DataStax has done, all of the sort of open source, available open source secondary index implementations have been column attached or column oriented, at least.
Yeah, because that was the whole point of secondary indexes. I want to query a column that's not in my primary key, and use that in my where clause. But right, so who would like to pick on secondary indexes? I feel like Brandon's got the longest run there. But how is this different? Or like, what is this meant to replace secondary indexes, the classics? Don't make me pick a name.
Yes, we
Someone
want to
take
replace the secondary index because by design, the secondary index is to create a local table that put the index column as the only partition key. Once you have like a lot of matches, which means it will be a fat partition, your fast performance and stability. And it also does not support like query with multiple secondary index together in one read request. And it does not support tokenization, etc. It also consumes a lot of disk space. And
Yeah,
on top of that, it's hard to maintain consistency. For example, when some of the data lost in the secondary index table, we can't just repair the missing parts because the secondary index is a table itself and it does comparison, etc. With SS table attached strategy, we can easily repair and fix broken indexes. And we can also leverage the zero copy streaming, which means that we can string index file together with the SS tables. So we don't have to rebuild them on the receiver side, which makes bootstrapping, etc. much faster. Yeah, that's all.
Yeah, that sounds really awesome. So there were, we should talk about some of the outstanding issues right now that, I mean, the CEP is a proposal, but what are some of the outstanding issues right now? This is for 5.0, or I'm sorry, post 4.0, obviously, with maybe 5.0, I don't know. But this is,
I have a Jira is 4.x. That's
4.x. Okay, yeah, there
so,
you go.
So who knows?
We'll just throw a breaking feature in the middle of this. Let's do that.
Too early to paint that picture.
Exactly. So it will not be a part of 4.0. I think that's safe to say. Code freezes do that. But what are some of the outstanding issues and what that we should discuss right now?
I have a agenda for discussion. Can I share slides or I just read it?
You can share if you want. Yeah.
Okay, just 2 slides.
I think you have the ability to do that. You do.
Okay.
Yeah, I see it.
Right on.
Just want to share our draft plans. And the first step is currently where we are is in the community discussions. And we hope to get some committer review on the design door and the committers that they know SASE and indexing well. And after we get some consensus on the design door, the next step we want to do is to merge the the next step is to merge the index group interface into Cassandra, because this will be less invasive and easier to review. It also brings some benefit to the SASE as well. And so the question is, do we need a mailing list vote for merging the index group?
Well, it's just a new interface, right?
Yeah, just a new interface.
You're just talking about the index group changes?
Yeah.
I mean, nobody's forced to implement it, right? So just add it. Who cares?
Yeah, we can just change secondary index and SASE to make sure that they're compatible and still working. So the last step after the index group interface is merged is to merge the actual implementation of SAI. So what do you guys think about?
I mean, broadly, that's about right. Have you guys talked any more about whether you want the default create index DDL syntax to point to SAI, in the first OSS version that this is released in?
The question is, are we marking it as experimental after we merging it, or like when can we announce it as production ready?
Well, I mean, ideally we want to say it's production ready when whatever's after 4.0, whatever major is after 4.0 comes out. And I think that we'll have more latitude to, well, we'll be able to do that with a clearer conscience than we have ever in the past. I mean, by the time this happens, we'll likely have, things like Harry that are exercising it. There'll be more testing than probably any other major feature we've ever released. But yeah, no, I guess I was just asking more about, it's a minor detail, so we don't have to spend too much time on it. Just, I mean, eventually we probably want to be in a place where create index is just delegating to SAI. But initially, if we use the custom syntax, I don't think anybody's really going to care.
And also
I'm not sure we would need an ML vote for the index group thing.
Okay,
go back to that one. I mean, that's my mental model of project governance is not the best, obviously here, but it's not really it's not a new feature. It's not a huge new enhancement. It's just it's API flexibility. So I mean, it needs review, obviously, but I mean, given that it changes APIs, but unless we're concerned, there aren't really like external implementations of the secondary index API that we're going to be super concerned about breaking. I mean, there are people out there like Alessandra and others that might care, but that's their problem, I guess.
We can help them to migrate.
Yeah, it's not going to be rocket science to do it. And there will be examples of exactly what they have to do.
And would it be painful to remove if it turned out not to be a good experimental feature and for some reason we discover something new and it has to go away? Any downsides? And that's the only thing I can see about having a new interface that could be potentially difficult to remove if people start relying on it and it's a bad interface.
I don't think it would be painful to, well, I mean, to be pedantic, it's modifications to an existing interface. I don't think it would be very painful to I don't think it would be too painful to go either direction. But I mean, once the changes are in place, it's I don't think it's painful to keep it or revert it on his head, whatever ends up happening.
And as you said, it's a modification to an existing interface. So you were saying it might only break Cassandra. Who else could it break?
It would only break things like DSC search or Alessandra, things that third-party things that rely on the secondary index interface.
Okay, and have there been changes to that interface anyway since 3.0 shipped? Sorry, 3.11 shipped?
I think the last major round of changes were SAM's changes in 3.0.
I think the last changes was for SASE.
Which was 3.0.
Okay.
Yeah.
Okay, so you might break some stuff that's worked for a while.
No, we definitely didn't call a vote for that.
Yeah, internally, we already have basically singleton group implementations for SASE and legacy secondary indexes, and those have been running in the DSC test for a long time. They seem to work reasonably well. So there's I think we at least have experience with those, and so I don't think there wasn't really too much pain in doing that when we did it. Yeah.
Seems reasonable then.
Yeah, and yeah, I mean, I think even if we have some strange future where SASE lives longer than we thought it would, the concept of index groups is something that really any SS table attached indexing solution, no matter what it is going to have to go there. Eventually, it's going to have to leverage that concept, or they'll just be. It's unlikely there'll be any way that it can be defensible from a resource usage perspective and so on. So I think the likelihood of it being removed is low, at least, or being reverted is low.
Yeah, because you also benefit SASE.
Yeah, if SASE were to take advantage of it, SASE could benefit from it as well. Yeah.
Without change on disk, you mean you could just update to use the new API and have a more efficient implementation rather than having to do a migration to SASE's on disk formats or any of that sort of thing?
Well, I think if you were to try to take SASE and leverage the index group stuff, you would essentially just end up with SAI, more or less. You'd end up with the way you'd have to link information between the column specific bits and the SS table specific bits, you'd most likely end up coming up with structures that look like what SAI has done. So it wouldn't be like a plug and play, like a trivial thing that SAI could do to take advantage of it, but it would almost certainly involve changing at least some of SASE's on disk organization.
Okay. And is there a reason that you couldn't evolve SASE into this system, given that you're describing it as being somewhat close and SASE could use this interface and those kinds of things? Why not incrementally extend the SASE format to give the new indexing types that we have here? And this is out of complete ignorance and having just looked at the docs a bit this morning.
So I'm going to, I'll answer part of this maybe, but then I kind of want to let Jason at least dig into this a little bit, because I know he'll enjoy it. So there are a couple things that we did that SASE might be able to benefit from reasonably directly, although I'm not sure. One is that when memtable index, so there are memtable indexes that index the active memtables, and then there are the SS table indexes. When memtable indexes flush, SASE currently what it does is it takes the memtable index, builds another on heap representation of the index segment by segment. It calls them segments, but the sort of chunks of the index by that it zips together afterward. It builds an intermediate on heap representation and then flushes to disk. And one of the things that Zhao actually did this, is SAI flushes directly from the memtable index, which is already ordered, essentially the way that we lay it out on disk, and we flush directly to the on disk representation of the index. That's something we might be able to transition to SASE, although it would, I mean, it would require a decent amount of surgery for the token tree writers and some of that other stuff. Although there's some other things I think that are just pretty core to the way the token trees and the indexes themselves work. And I don't know, Jason, do you want to talk about that at all? Because I can fill in details, but
just to clarify, which question are we talking about?
So it was just sort of a general bigger question for somebody wading in, not having done much research to understand things as to.
Yeah, I mean, the design doc is basically, we did a lot of stuff because I've done a lot of Lucene stuff, so I know all the modern information retrieval data structures that Lucene uses. So basically, we took those and redesigned SASE because we realized SASE just it's very easy to reduce the disk-based usage with SASE because the token basically was storing as the posting list. The posting list it's like the second part of the index. After
like in SASE, the postings lists are the token trees, if you're familiar with the token trees.
Yeah, which is just a long. So it's basically 64 bits versus probably on average between 8 and 16 or 20 bits usage per posting value, and those values are across. So that's multiplied by the number of columns that are indexed, essentially, right? So SASE was essentially multiplying that differential, the 64 minus the what we get, multiplying that out across all the columns. That's why you see the huge disk usage.
Yeah, so like with
that's
SASE,
only one factor. That's only one thing.
The postings compression is probably the biggest thing, though. That in
that's
terms
the biggest
of the disk
architectural
size,
difference. Yeah.
And so
to extend the existing format.
What's that?
Yeah,
so it's just a fundamental limitation in the existing format. You couldn't. It's not that you.
Yeah, the existing format is just like. I mean, I looked at it and I thought it was insane.
So the reason that I ask questions from that angle is I always think about what the operational story is of deploying something new like this. And you created secondary indices because you're having trouble querying your system on its primary keys, and you want to make sure that things are running well enough. If you were to extend something like SASE successfully, then perhaps you could gradually do some of those things transparently behind the scenes and gradually make things better as you wrote new data. Whereas I'm guessing you would have to create a parallel set of indices to the SASE ones. You would need to somehow indicate to Cassandra which index to use first if you're doing this under load. How do you select which of the two indexing systems to use? Then you'd have to be happy that it was good and then remove the previous indexing system. Is that the sort of things you'd need to do?
Yeah, I think the two difficulties. So just to cap off sort of the previous question, then I'll get into that one. So so as we said, you have this sort of a little bulkier postings concept, the token trees per column, and what you have as a replacement for that in SAI is the postings for each of the column indexes. So the matches for particular terms and such are just runs of integers. There's runs of row IDs, and so those compress reasonably well. You get these small postings lists, and those row IDs map to ordinals at the SS table level rather than the per column per SS table level. And so they map to ordinals in just a simple array that allow you to look up whatever you need, row or partition offsets or partition or clustering offsets, tokens, and those offsets and tokens live at the SS table level. So the flowing into the next question, I think the first difficulty I think you have with trying to have SAI and SASE coexist in sort of a transitionary way is that SAI isn't replacing SASE structurally, in that it's just another thing you can attach to index particular SS tables and then try to put an interface on top of that. And what's above that in the query pipeline is largely the same. They're different basically all the way up the stack to the searcher. I think that's probably one of the that's one of the difficulties. And then I actually am forgetting the second one I was going to mention. But
you should use an index.
Yeah, and then the other thing is, even if you, and so the other thing, there's two more things actually. The second one is that if you, even if you do that, you still can't even use SASE itself once you get to the 2-3 index columns. So there's that. I mean,
I guess I'm talking about replacing existing
Yeah.
use cases. I mean, new use cases,
Yeah.
run up SAI, you do all your testing, you populate your cluster, you check your queries are all good. I guess what I'm interested in is for people who are trying to convert a production system running SASE to running SAI or some other index.
Yeah. Luckily, if someone is using SASE in production, well, the only people
They probably
I've
aren't.
ever heard of using SASE, the only people I've ever heard of successfully using SASE in production are some 2.1 users at Apple, maybe. Like some
For the original
thrift-
use case. Yes, it was the
Yeah.
original use case it was built for. When Pavel built SASE, there was a very specific thing that he was working on. And I think it's currently being used for that. And otherwise it's not, because if you look at the way that it does tokenization and ranging and things like that, you could see like, oh yeah, I think this is built for a purpose, which is great in open source. I mean, if you have a scratch, itch it. It just isn't a general purpose use case. And unfortunately, when people saw this, they're like, oh, now I can do relational queries on my Cassandra database, and kaboom. That use case did not transport.
Yeah, so maybe it's a complete non-issue that I'm asking about.
Well, and then the third thing is like right now, so SASE always, when SASE was released, and well, basically always, it sort of just hijacked the selectivity stats, and I think it literally just provided like negative, like long min value or something as a selectivity metric for the read command. And so if you had a SASE index, sitting on a column, you'd always select that index over any other secondary index attached. And then internally, SASE would actually have a particular column index selected, and then if you had a Boolean query that could hit 2 or 3 SASE indexes on the same table, the logic for executing that AND query that Boolean query was actually sort of buried below the searcher level. So you'd actually, you pick the particular column secondary index, you get that searcher, and then below that, it was sort of laterally move out and use the other SASE indexes that were present if they were, if you had any. And so we didn't completely rewrite all of that logic. At some point, we want to pull that up a layer so that that sort of query optimization logic is not as like embedded below the searcher. But we'd have to do that essentially to play with another secondary index implementation.
Yeah, maybe I'm being overly specific by saying SASE. I mean, any other indexing systems.
Yeah. We can't even. The legacy secondary indexes have never supported Boolean queries anyway. So I would hope from a use case perspective, we wouldn't be in trouble there, at least, since it's just not something anyone could have done before anyway.
Mm-hmm. Okay.
There's another question I think related to this, and this has been feedback from the community on SASE, was that they just aren't performant when you use them, unless you really hyper tune your query. They don't have any performance attached to them at all. So
Performance problems with secondary indexes? Never
I
heard of such
know,
a-
really. Does SAI, what's the performance characteristics with SAI? Is it the same warning that secondary indexes would have, where you use them for convenience, not for speed? Or does it eliminate a lot of that?
It should be pretty fast.
I mean, what's,
Still
I've heard people
I mean,
ask, what's the
There are a
hit?
couple different ways to answer this question, Patrick. I think, and one is, I mean, architecturally, it's still a secondary index, and Cassandra's still a distributed hash table, and there's nothing really about changing the local index formats to be more efficient or for local queries to be faster that directly addresses things like, well, if you really want to scale, partition or token restricted queries are probably going to be easier than queries that go out and hit, you know, and divide by RF nodes, or more if you're not at CL1, that sort of thing. Does that make sense, Patrick? So
Yeah,
there
no,
are things that
does
there are
make
problems that
sense.
affect all secondary indexes
Right.
in a system like this. So, you know, while we've made improvements, I mean, some of them are still only in DSC and haven't made it to open source yet. There are improvements that we made along the way to both the correctness and the performance of the range read algorithm, which all secondary index queries start in and rely on. Like number one, the whole saga of making sure that we can't get stale results at quorum or at CLs greater than 1. This was Cassandra 8272, 73, and Cassandra 15907. And now that's in kind of a good place, I think, where we have the tools to make sure that's correct or fails obviously or whatever. But then also there are things like in the range read algorithm. So Zhao remembers this, I'm sure, pretty well, especially when we have V nodes. The current range read algorithm was not grouping requests by endpoint. And so you can have situations with a lot of V nodes where you would make a long string of individual, V node or token range requests as part of an index query. And in the case where secondary indexes work best, where you're getting few results, or this index is going to work best, like from a user perspective, where you don't have that many results, you're going to have to contact a lot of those token ranges to get what you need. So that could blow up in terms of performance. So there are things like that we've done, but there is still some of the limitations of historically of secondary indexes are there and are just hard problems.
Well, it's a distributed system, so there's no magic.
Right.
Quote
for
Dewey High.
local, from a local perspective, the changes are vast. I mean, in terms of like the just read and write performance, I mean, that's I don't know if you have in the CEP, I think, Jai, you guys have the disk usage stuff, but I don't know if you have like the write throughput testing numbers or anything, but I can let you guys talk more about that stuff. And Jason, as part of that, I mean, you might want to touch on some of the internal posting stuff and the struggle that SAI or SASE had with like large numeric ranges.
Well, SASE merges the segments at the end, and we just write segments. So I think that's probably one of the bigger things we did. I don't really want to. I don't remember all the details of SASE, so.
Sure.
That's okay. This isn't meant to be a prosecution of SASE. I think there were some great questions John posted about. I mean, because SASE's been in the community for what, 5 years now? It's been there for a while. So
yeah,
it's the devil we know, or the
It's
devil
already
we don't want to
convicted,
know.
isn't it?
What's that, Brandon?
It's already convicted, isn't it? No need to
It's
cross it.
convicted. Yeah, well, yeah, exactly. Well, this is why we're here today. But I just kind of teeing off of John's questions, which are really good. I mean, there's going to be a large group of people who are going to want to know, hey, this has been around for a while. What up?
I like to think of Zazie as Sean Penn and Dead Man Walking.
Okay, that's cold. Reminder, recording, Caleb. All right, that's fine. All right, just keep in mind that we have 20 minutes-ish left. So, Zhao, do you have more? We got to slide 1. What else do we have?
One more thing is how are we going to maintain 3 different index implementations inside the Cassandra code base? Is there a lot of problems, or is it okay? Or do we put each of them into a sub module so we can have different maintainers for different modules?
That was from the mailing list. Do we modularize all these different implementations?
You mean and have them out of the main tree?
Yeah, under Cassandra report. I think one of the good example is Presto. It has many plugins and Cassandra connector, Kafka connector, and each of them is in a sub module, and they may have different maintainers. And this will definitely speed up the development and testing.
Really?
Yeah, I think so.
I mean,
For something that's destined for deprecation and removal, I mean my disposition would usually be not to do that. I mean, for something that we have a commitment to maintaining long term, that's behind a very well defined protocol, as I'm sure is the case with like the connector, not even interface, but like protocol. I mean, I think separate modules would make more sense, but yeah, my instinct is I want to avoid separate projects altogether. I don't know.
yeah, and I suppose the only reason that I can see for different modules being valuable is if it had to live across different release lines with the same code or something like that, as if it was like a plug-in to an external service. But something core to the database like that, it feels like you'd end up having to do maybe 2, 3, 4 repo commits if you had to modify the secondary index implementation, Python detest involved with it, in JVM detest API, and the repo itself. So it just feels like additional maintenance headache. I mean, if we crack...
Then you have to call a vote for the in JVM detest API or use a snapshot.
Yeah, exactly. So it feels like unless we came up with a stronger multi-repo solution first and stronger governance for it, then it just makes things slower rather than faster to me. But I may be wrong that it's going to be different. Let's say we're managing on the 5.0 and 6.0 lines concurrently or something like that, and it's the same repo being used. But that seems unlikely unless you break it into some sort of engine doing the indexing and code that interfaces with the current Cassandra. But they seem somewhat intimately tied to SS tables. So if those formats are going to live on in the main repo, then it just seems like you're making work for yourself.
Yeah, we haven't talked much about the syntax, but one thing that might, I mean, it might be obvious, but one thing that might be good to call in the CP2, or at least clarify, is that I don't think there's a single point of, I don't think there are any compatibility issues, especially on like the DML side or on the query side in CQL. So I mean, I think basically any, assuming, you know, once we hit the feature parity, any query, any existing index query in any existing application should just opaquely continue to work if you were to transition that application from like legacy secondary index to SAI. I mean, thinking about the entire migration story, you know, there are some scattered secondary index users, legacy 2i users. Nothing has changed about that, right, John?
That question
Did,
was
oh yeah, I was just saying nothing has changed about the query syntax compatibility picture, right, John?
No.
Okay. Yeah, I mean, using the only point of difference I could imagine would be potentially having the create custom index stuff initially, there until we were ready to make the default SAI.
Yeah, it seems to make sense. Just add it as in the same way as SASE is right now, where you can opt in and use it, and then that would give people the chance to do this sort of benchmarking, work out what sort of resource constraints you might need. Those are the sorts of things that I worry about operationally, right? You say, hey, I've got my great new indexing system, and then pathological user number 7 comes up and starts running it, and you blow up in some weird new dimension of memory usage and trash things. So if it's opt-in and people can play with it, that seems like win-win. And then you go through and then you do the dull months of benchmarking work and convince yourself it really is safe to use most of the time. And then in a future major after that, you flip it to be the default once it's proved itself.
Yep. Yeah, I think so. I think the fun thing is that I think that when we look at the types of queries that it will struggle with the most, I'm not saying that struggle in an absolute sense, but the things that it would be where it could struggle are things that existing secondary indexes don't even support, and things where SASE does even worse. So
I mean, it seems like it would struggle if its index entries got split across very large numbers of SS tables that it had to merge.
Yeah, and I think that's another good thing to talk about a little bit for transparency and for anybody watching this. So we talked a little bit about the kind of basic distributed elements of why a secondary index can be hard, or what kind of scalability problems you can have with an information retrieval situation like that, where you're having to span a lot of the cluster to answer a question or serve a query. At the local storage index, the biggest risk to SAI or SASE or any SS table attached indexing scheme is going to be SS table proliferation. It's going to be the number of SS tables that you have to search over and collate results for to answer a query. So, with like size tiered compaction, you're probably not going to run into too many problems. We've tested extensively there. LCS will be interesting because your performance will degrade as the number of SS tables increases. Probably it's going to be the case that we will have to have some guidance around things like min SS table size for LCS. I think that we will benefit from future developments and new compaction strategies, which I think are on the horizon after 4.0. But yeah, that's something that both SAI and SASE will have to come to terms with at some point. Is
interesting you mentioned compaction, because that's one of the things I was thinking about is since this is attached to the storage engine and directly to the SS tables, compaction now, I mean, what does that mean? But you're saying we may have different guidance on parameters on compaction strategies, especially LCS, or would that also go with other compaction like time window or something like that?
Yeah, I mean, you have a basic impedance mismatch between doing point queries and doing index queries for something like LCS. LCS, if you are doing partition restricted, token restricted queries, SAI will be blazing fast, and it'd be great because you're gonna be narrowing in on a particular SS table index, querying that guy, and everything is fine. Although again, even in that case, the more SS tables you have, the worse your compression factor for terms and actual index data gets, right? So, you know, the fewer SS tables you have, the fewer terms dictionaries or whatever other index structure you have, you know, over here for the actual compressed index data. But yeah, we may end up having to have, we need to have operational hooks and visibility around how much SS table count correlates to query performance. I mean, we have that already in tracing. We have that already in the metrics that already exist for SAI. But we're gonna need a complete conceptual picture for operators about how the relationship between SS table count and query performance, like what that relationship is and how they can take steps to move that one way or the other, if that makes sense.
Also, recently we have improved the performance for LCS by lazily searching the SS tables, so the query doesn't have to search all the large number of SS tables. This brings us closer to the size tier compassions.
Yeah, I can imagine somebody setting up some sort of time series data with time host measurement and then adding a secondary index on the other thing and having a really bad day.
Yeah, and the other thing that we need to do in the long term is that we need semantic, we need TWCS, but with user specified like temporal value rather than just a mutation timestamp. Because a lot of the nice use cases for this and any other index are going to be, they're going to be temporal. I mean, they're going to be time range bound. This is, I mean, financial, like transaction processing. There's so many things. Sensor networks, there's so many things that are going to benefit from that. And what will get there, if we can make that happen, is we get great search space reduction. Just, you know, if we've got 1,000 SS tables, but we have to search 3 because that's today, those queries are going to be able to ignore the vast majority of the possibly searchable SS tables, and we're golden. It's one way to get denser nodes for particular query patterns without doing anything magical.
As long as the node that's serving today doesn't get just destroyed by everyone looking at today's data.
Yeah. Yep. So.
All right. Well, with 5 minutes left, and oh man, my Zoom this is funny, but it's causing my computer to shut down. So if we make it to the end of this, it'll be a miracle. It's now using 250 gigabytes of memory. I don't know how. I think my MacBook is going to melt through my desk, but it's still on. So this is like a Cassandra cluster. You can abuse it and it stays online.
I didn't realize it was Chrome based.
Yeah, exactly. Wait a minute. When did they start using Chromium? Anyway, so we have a few more minutes. Any last minute fill it in the blank things that need to be brought forward? Probably more importantly, should we do this again at some time, and why?
Well, I mean, maybe, is there more broadly like a question of where we're going to go with the CEP, and, you know, when we're going to have prototype code ready, and kind of how those things are going to relate to one another? I'm not exactly sure. None of us have really done CEPs before, right? I mean, so it's kind of.
That's a good question. CEPs
like
are
we all know
newish.
there's code. We all know there's a prototype that exists.
Yeah.
Yet the CEP is here as well, and like I'd like to get to the point where, because I think the one thing I mean, talking to Petrov a little bit, the one thing I think some people might be a little bit confused by is that like we know, like everybody knows we have the prototype, and yet we're asking for feedback on a CEP, which most of the time, like the CEP is going to be something that where code is not already written. And so there's a question of like how genuine the request for feedback is. you know. I mean, I think the best we can do is trying to encourage people to give feedback like the code is not there already, and just try to at least make sure that we have good benchmarking, good, we have proof that things work well in important cases, and then hopefully we just get to the code.
So
the sooner-
I think the thing that you need to separate is the difference between having working code and railroading something in, right? I mean, so working code is a great thing for community feedback. So we've got the CEP, it describes how it works. You could provide more detail for people to look at. It's not like by providing feedback, they're going to create more or less work on things right now for you. So it seems to me that sharing it earlier would be good, but just because it exists doesn't mean it gets approved and merged instantly unless the community agrees, like it would have done if you'd skipped the other processes, right? Just because you have it doesn't mean you should take it.
Yep.
Yeah, I think that's 100% accurate.
Yeah, and having more detail, for instance, on so like Petrov, Alex had some particular concerns about the try versus B tree decision that we made especially for text indexing, and so we going a little bit deeper into how that works, for instance, whether that's we actually have code that's available, or we talk a little bit more about that at a high level.
And if someone wanted to do an experiment like that and replace the tries with B trees, then they could do it on top of the existing code, right? Rather than have to re-implement the whole CEP themselves and then test it.
Yeah, exactly. Once you actually have working code, you have more latitude, and the community has more latitude to. The community at large can take initiative and say, like, okay, well, here's an alternative, and let's look at it. Yeah, and I mean, for that, you probably want to get to the point where you have like a common benchmarking framework that can help you make the decision and all that stuff. But yeah.
Yeah, I mean, as you say, common benchmarking is important. Having multiple people be able to execute those benchmarks, I think, is important beyond just a single set of contributors. Like a single organization shouldn't just do it, more than one should do it. A bit like the Netflix were able to test their messaging improvements, just to remove bias and to make sure it works in different environments.
Yeah. Yeah, I mean, if we get to a point where we're just bike shedding between tries and B trees, then hopefully we'll be able to broaden our horizons a little bit to think of whether there are some secondary concerns that suggest one over the other. Like if the tries are going to end up backing the primary indexes at some point in the future, that's something to consider in terms of whether having one thing that can do both of these well enough is better than having a B tree for CI and the tries for the primary index and all that stuff. So there'll be other things that we'll have to think of in terms of the second and third order consequences of that decision. But we'll get there.
All right. Well, I'm going to keep this on time for everyone. It's top of the hour. Let's continue the conversation in the mailing list. I'm going to go ahead and hit the end recording. Thank you, everyone. This is really interesting content. I'm going to probably get this up on the YouTube site today. So if anyone else, and I'll put this in the mailing list so that everyone sees it as well. But yeah, thank you, everyone.